What's up my people, and welcome back to Technological Journey episode 5. In the last episode we built the lobby room for the base. We also built an extra room to put our single block machines and our power infrastructure for early game. And then we also set up our applied energistic storage to digitize our storage system. The goals for today's episode are to set up the gold line, set up biodiesel power production, and also get our first tier 3 electronic circuits. That'll be a lot of progress through the quest lines, and it'll also allow us to have a much more sustainable source of power generation. So in between this episode and the last episode, I have done a couple of things. The first thing that I've done is I have added an extra coke oven to process charcoal into coal coke, and I have also added an extra large bronze boiler. Now this works perfectly because 3 coke ovens to 2 bronze boilers is a perfect ratio. That will allow us to essentially support steam infrastructure until we're able to get biodiesel later on in today's episode. I've also moved over our polyethylene line and powered it so that it's continuously running, which is useful because we can now use polyethylene to coat all of our cables instead of having to use rubber, which will save us a lot of mining trees. But on the topic of trees, I've set up this farming station down here to auto farm rubber trees for us, and I've also put some canola in here. Now this thing is just, it's not necessarily temporary, but it's not optimised at all yet. We're just running it off a single LV turbine, so it's not even getting full power. But these drawers here also need to be upgraded and put void upgrades on. But it's getting us canola seeds, rubber saplings, rubber and rubber wood. And the way that this works essentially is I've got 2 tools in here. I've got the flux saw and emerald tipped diamond hoe. Now these are both unbreakable tools when put in the farming station, because the flux saw doesn't use energy and the emerald tipped diamond hoe is just a simple craft like this, but it gives the diamond hoe unlimited durability. That saves having to auto craft wood tools and then refeed them back into the system. Now the reason I set up that farm over there was 1, so that we had some rubber resin which would help me make the cables while setting up this line here, and 2, because the canola is the key ingredient that we're going to need to produce biodiesel. Now biodiesel doesn't produce any more energy per second than steam does, because it uses single block generators just like this, although it is much more energy dense. And so instead of having to use 640 millibuckets every 0.5 seconds to produce 32 EU per tick, we only use 2 millibuckets every 0.7 seconds to produce the same amount of EU per tick. So it's much more energy dense, and it essentially allows us to move the fuel and power on site without having to use as much space as we've used here. I've also got a blast furnace up and running, which is just producing us passive aluminium. I say passive, we still have to put in the dust, but that's not particularly difficult to get. Now in the comments of the last video, somebody did say that a better way to automate these would be to use conveyors, and then we wouldn't have to use these ender conduits, which are taking up a lot of space. Although I did decide against that just because conveyors are a bit of a pain to craft at the moment. They're not necessarily difficult, they just take a bit of time. Although once we switch over to interfaces and things like that, I will be able to remove these conduits here. Right, so the first step we're going to take today before getting our biodiesel power is to set up some basic automation and auto-crafting. Now when I say that, I'm talking about using interfaces. So if we just look up the recipe for an interface here, they're actually quite cheap in comparison to something like non-factory. All we need is a machine hull, 4 LV pistons and 4 quartz glass, and that will get us 2. And if you upgrade the tier of piston, you actually get more. But I'm just going to use LV ones for now because the next tier is HV. So what I want to do with these is I'm going to place them on top of these machines here, and then we can hook that all up to our applied logistics system, and we should be able to start auto crafting. Now another key thing we'll need for that is we will need applied logistics patterns. Now these only take an LV circuit and polyethylene and some steel and some quartz. So the bottleneck here is most likely going to be steel, although that's not too much of an issue because we can use our time in a bottle on this to make steel relatively quick. And the next step for steel is to combine oxygen and iron in a blast furnace, which will basically make us steel at a quicker rate. than this primitive blast furnace over here. Although I'm not going to set that up just yet because we will need more oxygen to do that, and I want to wait until we have a centralized fluid storage system for which we can export oxygen directly to an EBF. So like I thought, the bottleneck was steel when crafting all of these components here, but I should have everything we need to get going with our automation. So to craft the interfaces, I don't think we actually need this polyethylene here anymore. I just did that because I need to make some applied logistics circuits, which I've already gone through. So to make the interfaces, I think we need the pistons, the LV machine holes, and I believe it was 40 quartz glass. And this should get us 20 interfaces, which might be a bit overkill, but I mean, you can't really go too overkill with interfaces because you're going to need them throughout the entire game, you know what I mean? And while those interfaces are crafting up, I'm just going to go over to the terminal and craft up a pattern terminal, which is essentially what we need to encode our patterns to make the applied logistics recipes. And for that, we just need a crafting terminal, which I've already talked about, and some sort of processor. If I just look up here, an engineering processor. So I crafted that up, and now we have a pattern terminal. And if we just add that onto our network by placing a Fluix cable and that there, you can see we have this interface here. This slot here, you put your blank patterns in, and then you encode a recipe into here and press that, and then you can put it into an interface. You can also switch this over to processing, which essentially allows you to outsource to machines, which is what we're going to be doing initially because we don't have any molecular assemblers yet. Although I think we are going to get into some of these relatively soon. They do look pretty cheap, to be honest. It's just, I'm assuming, yeah, it's just some applied logistics circuits, which isn't too much of an issue. It just uses polyethylene. But yeah, our 20 ME interfaces are finished crafting. So now I'm just going to put some bits and bobs in here to make the patterns, which I believe is this. I think this is where we needed our polyethylene. Yeah, and then this should make 8 patterns per recipe. Yep, that's lovely. So 8 patterns in here, and I think I crafted up enough for half a stack. We shouldn't need more than half a stack of recipes right out the gate. And then if we put these in here, we can encode our patterns. I also crafted up all of this Fluix cable, which will just allow us to create some temporary wiring tunnels from the terminal and controller there over to where we're actually going to set up the interfaces. Now at the start, I'm not going to focus too much on designing some nice tunnels. I'm just going to make sure that they sort of align with the base. So I set up the wiring tunnel just under here from our controller down through here, and it pops up over by where the machines are. Just here, this here is the line with the machines above it. And I also got the bits and pieces to craft some molecular assemblers. We should have enough of 4. Although, as I was crafting those, I realised that we needed crafting storage as well. Now that's a bit of an issue, because we only have the ability to craft 1k ME storage components, which means that we can only get 1k crafting storages, which even though it should be enough for the moment, just for these basic recipes, I think we probably want to focus on getting an MB assembling machine before we actually do this automation that I was thinking of doing. And that makes sense as well, because then we'll be able to set up different assemblers with different fluids, and essentially I think we just should hold off and it'll make it a lot easier when we set it up. And it's not 100% necessary right now. So the goal there, in order to get the advanced assembling machine, would be to get these tier 3 circuits. Although before we get these, we are going to need to invest in biodiesel power. So that is what I'm going to do now. So on screen now, we have the biodiesel flowchart loop. But you can see on the left here, so we have the farming station which will produce canola. So I'm going to upgrade the power on that to use a MV turbine, so hopefully that will work a bit better. I'm also going to put void upgrades on the drawers so that it will keep running even when some of the drawers get full. And essentially we just need to use these canola to create refined canola and crystallized canola, and then combine that in a chemical reactor with some creosote oil, which we're going to get from our coke ovens, which are going to be repurposed, and then that will make us empowered oil. And then we combine that with methanol, which we make through the line at the bottom, and that will get us to our biodiesel. Now, in order to get that, we also need sodium hydroxide dust. I think we actually need tiny piles, and it might be small piles, but the best way to get this is through clay electrolysis. Clay dust electrolysis, sorry. Although, for that, we'll need to set up a cobbleworks. So a temporary solution here is just going to be electrolyzing salt water, which will give us chlorine, hydrogen, and sodium hydroxide dust. and this salt water is just made by combining salt and water in a mixer. Now I am going to do that process just by hand, just because we're not in need of too much, so it's not going to be a fully passive loop for biodiesel, but it should be enough. And our current power anyway isn't technically fully passive, because we do have to put this wood in here. Okay, so I've crafted up all the bits and pieces we need, except from an end of war, to set up our biodiesel power. And I've made this line here. At the moment we're going to be powering it with steam, although obviously once we've produced the biodiesel it should be self-sufficient. So the first step I'm going to do is I'm going to go ahead and place down a basic chemical reactor, and I'm going to place that here. Now the reason I haven't put that on the end is because then we can chuck down a fermenter and a fluid extractor like this, and then we'll put a drawer above here. Now this section here is going to be producing us refined canola. It'll take in the canola seeds here, it'll fluid extract them into canola oil, and then it will ferment them into refined canola, and then output it into this chemical reactor here. I'll configure all of the inputs and outputs and everything with pumps and conveyors and all of that in a second. But then what we need to combine with refined canola is crystallized canola, which uses a laser engraver and a glass lens. We put that in here, and then we put the canola up there, so that'll be input into there, and then they will both be input into this chemical reactor here. And this chemical reactor is going to make us crystallized oil, and then it's going to be extracted under the bottom with a conduit and put into another chemical reactor right here. And then I'm going to put creosote oil into here as well. For now I'm just going to put a drum here, and we're going to go grab creosote oil from down there and move it over. In the future we'll obviously automate the moving of creosote oil from the ovens over into this here, but for now we'll just use a drum. And that's going to make us empowered oil. Now this empowered oil will go into the final chemical reactor to make biodiesel with methanol. But first we need to produce the methanol. So first I'm going to place down a macerator, and I'm going to place a drum on top, and that'll be for charcoal, which will come out of our ovens as well. And that will make us charcoal dust, and then that will go into a basic centrifuge, which will turn the charcoal dust into carbon dust, and then that carbon dust is going to go into a advanced chemical reactor, and it's going to be combined with oxygen and hydrogen, which we're going to get through water electrolysis. But I'm going to leave a gap here for a drum because we're going to be producing excess oxygen, so the excess oxygen can go into here, and then we'll also just, because we're producing excess hydrogen over here, we can just switch these drums around every now and then to fill up the backups in this system and the backups in this system. I mean, not the backups, the deficits. So this is going to be making us methanol, and then I'm going to place one more chemical reactor down here, and this is going to take the methanol from here and the empowered oil from, where was it, from here, and it's going to combine it into biodiesel and glycerol. Now glycerol is just going to be a byproduct for the moment, but biodiesel is what we want. So I'm just going to set up all of the wiring and the end of wire to input water into here, add some conveyors onto these things and configure all the outputs, and I'll catch you once I've done that. Right, so I've configured everything for the biodiesel setup, and I've also made some sodium hydroxide dust just through electrolyzing our salt water. And now if I convert this into small piles, or tiny piles I think it is, of sodium hydroxide dust, and we put this into this drawer which has a conveyor on it, it'll then put it into here, which obviously has methanol and empowered oil, and we should see our biodiesel and our glycerol come through. Now I've set it to this drum here to fill up with glycerol, and then this tank here which I've just put 3 red dyes on to fill up with biodiesel. I put this directly into an ender tank because then obviously we can transport it around the base. And I'm starting to think actually, because this is buffering here, that we probably want to somehow buffer biodiesel before it goes into the ender tank, because I'm not sure if 64,000 millibuckets of biodiesel is going to necessarily be enough of a buffer. The limiting factor here seems to be the empowered oil. Oh, I think that probably gets created here. Yeah, so the limiting factor is the creosote oil. So I'm thinking I'm probably going to put creosote oil into an ender tank for now and just transport it directly over from those ovens. And I might also put the charcoal in an ender chest and move that over to there. Obviously all of these ender tanks and chests are going to be replaced with applied energistics, fluid and item buses of some sort. But the next step once I've done that will be to convert all of our existing power infrastructure running off of steam here into biodiesel generators, and then we'll be running our base off the biodiesel which we're producing here, and that will allow us to have the power necessary to work towards our tier 3 circuits. Right, so I've done a fair bit of work since the last cut. The first thing I did was I repurposed these coke ovens here to run off of wood and produce charcoal and creosote. I also decommissioned this bronze boiler, so it's no longer producing steam, and we only have this one producing steam. And the reason I did that was just so that we can still run the steam oven and the steam macerator, because they require steam. The rest of the infrastructure in the base, I mean apart from this bit here, I've set up here on diesel generators. So advanced diesel generators here, and I've run the blast furnace off a diesel generator. I've also moved the AE system over to a diesel generator, and the only thing I have left to do is the farming station. I also tore out the machines that I had here so that we can put a chemical line here, or some sort of small processing line. And this section here will get torn out for a processing line at some point as well. And I decided to do that so that we can put our single block machines in this middle section here, because it's 4 wide and otherwise it won't all be centered, which kind of annoys me, I'm not gonna lie. But the main thing that I've done is I have crafted up an advanced electrolyzer and an advanced assembling machine. Now I know I said earlier that we can't craft this, but I was wrong and we can. So that allowed us to craft up a 4K crafting storage. Now with that 4K crafting storage and 2 other co-processing units, which are the purple ones here, I just created a very temporary auto-crafting setup just around the back of our ME terminals here, with an interface, 4 molecular assemblers on each side, and our crafting storage. And that's going to work in tandem with this little setup here, which is where I'm going to place all of our single block machines, or as many as we can power off of one line for now. And we're going to have interfaces behind the single block machines, which are being powered down here by some diesel generators. So the first machine that we're going to set up on demand is our MV assembling machine. So the way that we're going to do this with the majority of our machines is first we're going to configure an interface to output only to this side, so that it won't send any items to adjacent interfaces, which we're going to have in a line down here. And then we're going to configure the actual machine itself to have its output face on the back, like so. And then we need to go into the machine, and we need to turn on auto item output. Now what that will mean is essentially that the interface will export the items required for the pattern into this machine, and then when the recipe's done it will export them back into the interface, which will put them back into the system, which will complete the crafting recipe. Now we don't have to do this with all the machines, but with machines like the assembling machine, the alloy smelter, things like that where recipes can get mixed up, I'm going to turn on blocking mode on the interface, which essentially means if there are items in here doing a recipe, it's not going to send through the next recipe if we request more than one recipe at a time. And that will just stop recipes getting muddled up and sort of messing up all of our crafts. So the next thing I need to do is I need to connect this interface to our applied logistics system, which should be as simple as just placing a couple of Fluix cables. Now we should only have to connect one interface here, because all of the other interfaces which are going to be along the line will have will transmit the applied logistics. Well, it would be the channels if we had channels turned on, but it will transmit the network signal to the interfaces if they're adjacent. So I'm just going to go ahead and set up a couple more machines on this line here, probably make it a bit longer, and then I'll show you what patterns we're going to encode to start with and how we go about doing that. So I set up, as well as our MV assembling machine, I set up our LV bending machine, our LV wire mill, our LV lathe, and then also our LV circuit assembling machine. Now the reason I chose this one was because this will help us make our next tier of circuits, which I talked about, and then that'll allow us to progress on to tier 3s. But before we do that, I'm just going to go over how patterns are encoded. So in this pattern terminal here, we've obviously placed our patterns here. So let's just start off by finding a recipe for something that we use quite common. So I'm going to go ahead and use tin wire. And then if we just click R for the recipe on that, and then we get the machine that we want, and we just click that into there. Now as long as this is set to processing pattern, we've got here 1 tin to 2 tin wire. Now we encode this recipe and it will give us a pattern. And if we press shift, we can see the tooltip for the pattern there. Then we can go ahead and just place it in the corresponding machine. So tin wire is made with a tin ingot in a wire mill. So if we go over to the interface for wire mill, and we just plop this one in here in the patterns tab, and then we go back to our crafting terminal. Now as long as those interfaces are connected to the wire and we have tin in our system, which we do, if we take all of our tin wire out here, you can see it says craftable. So now let's just craft one for the sake of it. And so that says use 1 tin ingot to craft 2 tin wires. We press start and it says scheduled 2 tin wires. Now it's exported that over to the wire mill machine and should come back into the system shortly. Oh, I forgot one key thing. We need to screwdriver the side for the output, and that will essentially allow us to allow input from the output face. But yeah, so now I've screwdrivered that, which will allow the input. They'll automatically output back into the interface. And then if we go over to the terminal, we should have our tin wire crafted. Yeah, so 2 tin wire in there. So now what that allows us to do is to start encoding recipes that we need in the future and just crafting them on demand rather than having to keep running over and putting things in the machines. And that speeds up processing rapidly. Okay, so now we've done that, we can start to work towards our next tier of circuits, which would be the electronic circuits. And in order to do that, we're going to need silicon wafers and silicon balls, which we can then turn into all these different wafers, integrated circuits, CPUs, RAMs, central processing units, all sorts of things like that. And they all come from these wafers, which are just made by cutting a silicon ball in a cutting saw. And to get a silicon ball, we need gallium arsenide and silicon, and we need to put that in a blast furnace. And to get the gallium arsenide, it's a simple recipe with, I think it's gallium and arsenic. And arsenic we're just going to get through ore processing of our crushed energite, which we already had in the system. So I'm just going to go ahead and get that sorted, and then we should be relatively set just to move into the first 2 sets of electronic circuits. We're going to need to take a look at superconductor wire at LV before we can get to H3 circuits, but that shouldn't be too difficult, it's just a couple of recipes to get there. I've got our first silicon ball, which I just got through the blast furnace over here, and I've got another one cooking up here. Now as you can see in the top left, it's a 450-second recipe at MV, so they do take quite a while. But in order to cut this silicon ball down into wafers and integrated circuits and all these things, which you need for the final electronic circuits, we're going to need to make a cutting machine. And this cutting machine takes tier 2 circuits, and I think we might as well start crafting up some tier 1 and tier 2 electronic circuits rather than batch crafting up another set of primitives in order to craft the cutting machine. So they're not particularly expensive. You can either do it this route here, which takes 8 resistors, 8 capacitors, 4 copper wire and a good phenolic circuit board. But I'm going to go ahead and do this second recipe here, which use refined SMD components. So to craft the refined SMD capacitor, we get 16 at a time, just using some polyethylene steel foil and rubber foil. And to craft the refined SMD resistors, we need a carbon dust, 4 fine copper wire and polyethylene, and that makes 24. Copper wire we already have. Soldering alloy is just soldering alloy dust, which is, I believe, antimony and tin, which is relatively easy to get. And then the good phenolic circuit board just requires a phenolic circuit board, which we can either make in an assembler with glue or with bisphenol A. Now bisphenol A is the more efficient recipe here, although this does take a little bit of processing to get done. And I believe we'll need to set up a coke oven, a pyrolose oven. So we're going to go with the recipe for glue, which is literally just centrifuging some sticky resin, and we also get some raw rubber pulp and some plant balls as well. Now that was very quick. I managed to craft up to 2 stacks of electronic tier 1 circuits in about the same time that it would probably take me to get the resources and batch craft maybe 6 stacks of primitive tier 1s. But we don't actually have the quest for these yet unlocked because we need to cut these wafers and everything. So what I'm going to go ahead and do is I'm going to convert a stack of these, or I think it's 63 is the ratio, into 21 tier 2s. And then I'm going to use those tier 2s to get the advanced cutting machine, the advanced precision laser engraver, and the advanced extruder, which are the 3 MB machines we need in order to get the tier 3 electronic circuits, which are our first HV circuits.
So let's go back to the beaches where I always make you laugh, to the forest where we found a hidden path, to the summertime of 2005, when we were still alive,
Right, so I've done the quests to unlock the processor and the electronic assembly. Now I just wanted to quickly mention why these weren't previously unlocked when I'd crafted them up, and why I didn't actually need these central processing units in order to get these. That would be because I downloaded something called, I think it's Staffix's Electronic Fix, which was recommended to me on the Technological Journey Discord, which I talked about earlier when we were setting up biodiesel. And essentially what that does is it changes some of the recipes surrounding the electronic circuits, and I think maybe the refined circuits as well. So normally these would require these central processing units, but what the fix did was it's just some code that you put in a script in your .minecraft file, and it just changes some of the recipes to allow electronic circuits to have more use essentially, because otherwise they're kind of useless in this pack. Like, you'll need to progress onto refined pretty much instantly if you hadn't downloaded that fix. But with that fix we still need integrated circuits and superconductor to get to our tier 3s. So I crafted up some soldering alloy and some gallium dust, and the first step to getting our superconductor will be to combine this in a mixer, and that will get us our LV superconductor base dust. And with this, I believe we put this in a blast furnace, and then that gets us to our LV superconductor ingot, LV superconductor base ingot. It's only a 1-second recipe, so it's really nothing too long. And then we need to turn that into LV superconductor base wire, which is as usual just in the wire mill. Now we have our LV superconductor base wire, we need to turn that into LV superconductor wire, which is what's needed for the tier 3 HV circuits, or the first tier of HV circuits, sorry. And then we just combine that all in here. But to get these superconductor wires, we need to put it in a assembling machine. It can be at low voltage, but we're going to use our MB one, with an integrated circuit 1, tiny steel pipe, and 2 electric pumps. So it is quite expensive. Well, it's not necessarily expensive, it's just quite annoying to craft up these pumps. But we'll be able to produce this in large amounts once we get some more robust auto-crafting infrastructure. But the thing that's new here is we need nitrogen, which we can just get from centrifuging air, which will give us oxygen and nitrogen, and we get air through an air collector. So I'm just going to set that up real quick on the back of one of these chemical lines, and we can just manually move it into the assembler. So this is our basic air collector, which we're just going to run at LV, and then I'm just going to manually move the air over into our centrifuge for now using a drum, because we don't need too much of this. It's just going to be when we batch craft our circuits. So if I just plop this down here, I don't want to place that drum there. If I just plop this down here, it should start to collect air, as you can see there in the top left. And if we just place a drum here, it will output the air into this. And then if we move this drum over to our centrifuge, which I think we've probably got placed over this side, and we just put it in here, it will centrifuge, I think it's 5 buckets of air at a time, into 3 buckets of nitrogen and 1 bucket of oxygen. Now we have some glue left over here, so I'm just going to get rid of that. Now if we collect the nitrogen from the centrifuge and we go and put this over in our MB assembler over here, we're going to turn off auto output just so we can do the recipe in here. And we chuck in 4 tiny steel pipes, 6 LV superconductor base wire and 4 electric pumps. That'll be enough to get us 6 LV superconductor. Then we just need to chuck an integrated circuit on 1 in here and we should be getting our LV superconductor wire. There we go, so we have 6 of them. And we get some soldering alloy, which I've shown you how to make previously. Now if we put all of these bits and pieces here in the basic circuit assembling machine, we're starting to create our tier 3 electronic circuits, which are our very first HV circuits. Now I've put enough in here for 2, but I'll probably batchcraft a couple of these in between this episode and the next. So with these first HV circuits here, we're ready to move into HV. We probably will want to get refined circuits as soon as possible just because they're the next tier up and they're probably a little bit cheaper once we set the infrastructure up. But we're now ready to move into the HV chapter, probably during next episode, which is really where the game starts getting fun, because we need to go to the moon in HV, we need to get titanium, all sorts of things like that. We also deal with some more fluids here, and then as soon as we're in EV we can start really beginning the pack with the big multi-block processing lines and things like that. But for now I think that's a decent place to leave this episode. So again, I just want to apologise for the delay on uploading this episode, but hopefully since it's a bit longer that kind of makes up for it, although I will try and upload more frequently. It's just this episode I had quite a lot going on and I was quite busy, so it took a while to get done. But anyway, thank you for watching episode 5. Please do leave a silly comment telling me what you liked about this episode, what you think I could change, any tips or tricks that you think I can add. And please do like if you enjoyed the video, and subscribe if you're enjoying the series, I guess. But that's about it. Bye.